right, let's do a few examples that deal with probability when you have cards. Okay, it says when a single card is drawn from a standard 52 card deck, what's the probability it will not be a king? Well, the probability it will be a king, there are 4 kings out of 52 cards. Okay, so if it said the probability it will be a king, that would be it. The probability it will not be a king is what we call the complement. Okay, in other words, what's the opposite of that? And you can get it by doing 1 minus 4 out of 52. Okay, another way to think of it is if 4 of them are kings, then you know 48 of them are not kings. You don't have to do the subtraction that way. You can think of it in your head, all right? 4 are kings, so 48 out of 52 are not kings. Now this will reduce. You always want to reduce your fraction. This reduces to 12 out of 13. And again, that would be called the complement. When they ask the probability it is not this, then it's called the complement. Let's look at another one. If a single card is drawn from a standard 52 card deck, what is the probability it will be a spade or a red card? Well, first ask yourself how many are spades. Okay, there are 13 of each suit. So 13 out of 52 would be a red or a spade. Plus, now let's do the red cards. Well, half the deck is red, the hearts and the diamonds. So that would be 26 out of 52 would be the red cards. Now you always have to ask yourself, did I count anything twice? Was there any overlap? And in this case, it cannot be a spade and a red card, so I did not count anything twice. You add this up and you get 39 out of 52. And let's see, 39 out of 52 will reduce to 3/4. So the final answer would be 3/4, which could also be written as 0.75 or 75%. Let's try one more of these. This one says, find the probability that a single card drawn from a standard deck will be a diamond or a face card. Well, let's start with diamonds. Okay, so diamonds, we have 13 that are diamonds. Okay, so 13 out of 52 are diamonds. Now let's talk about how many face cards. Okay, remember when it says or, you're adding. Okay, just the last example, I'm not sure I mentioned that, but when you see or, that means you're adding these up. Okay, so a face card. There are 4 face cards, nope, 3, Jack, Queen, King, in each set. So there are 3 hearts, 3 diamonds, 3 spades, and 3, what did I leave out? Clubs, that's the one. So we have 12 face cards. So there are 12 face cards altogether, 12 out of 52. Now you have to ask yourself, did I count anything twice? In other words, can it be a diamond and a face card? And the answer to that is yes. I counted 3 of them twice. So I want to subtract that back out because I counted them twice. They were diamonds and face cards. So what we end up with here, the probability that it's a diamond is 13 out of 52. Probability it's a face card is 12 out of 52. I have to subtract 3 because I counted the Jack, Queen, and King of diamonds twice. I counted it for diamonds and face cards. So I have to subtract that out. That gives us 22 out of 52. And of course that will reduce. You end up with 11 out of 26. Now, not every student does it this way. Some students start with the diamonds and say, okay, 13 out of 52, and then they say, okay, now how many face cards do I have left? And they'll say 3, 6, 9. They'll add 9, and they'll still get 22 out of 52. So you only want to subtract it out if you counted it twice. There are 2 ways to do this, okay? And if you do it step by step by step, you're probably going to count something twice. But if you did the 13 over 52 and then you thought to yourself, okay, I've already counted the Jack, Queen, and King of diamonds, so I want to make sure I don't count them again. That's okay. You can do it either way. It doesn't matter. You'll end up with the same answer.